There are other ways to do it, but since we calculate the equivalent capacitance first, the amount of charge that goes through this circuit, right, that way and that way, is the same amount of charge that would go to the equivalent capacitor. So we can say, well, we have an equivalent capacitor, and this is 12 volts, and this is 2/3 of a microfarad, and the amount of charge on these plates is C is equal to Q over delta V, so therefore Q equals C delta V, which is 8 microcoulombs. So 8 microcoulombs must travel to each plate, 8 or minus 8, right? So how much charge is on each plate? Well, there's 8 microcoulombs on this plate. There's minus 8 here, plus 8 here, and minus 8 there, right? So if 8 microcoulombs flows, that means minus 8 went to the minus plate and plus 8 went to the plus plate. I didn't write out microcoulombs because I don't have space to write all the units. And C, what is the potential difference for each delta V1, delta V2? Well, you can probably guess that it's going to distribute 2 to 1, so it's going to be 8 and 4, but which one's going to have 8 and which one's going to have 4? Well, delta V1 must equal, I always have to write C equals Q over delta V in order to remind myself. So delta V1 is Q over delta C, Q over C, Q1 over C1. So Q1 is 8 microcoulombs and C1 is 1 microfarad. So delta V is 8 volts, delta V1. And therefore delta V2 is 4 volts. It's the rest of it, right? Because the potentials have to add to be 12. So delta V1 is 8 volts and delta V2 is 4 volts. And that we've answered all the questions. So how do you know there's an elephant inside your house? Because there's a taxi out front with 3 elephants in it. So what about capacitors in parallel? Let's think about capacitors in parallel. Let's take a battery and a capacitor and a second capacitor, but not in series, they're in parallel. Okay, so let's say that the battery is delta V, capacitor C1, and capacitor C2. First of all, what is the voltage across each? What is delta V1 and delta V2? Well, because they're in parallel, we know that the voltages are the same. So delta V1 is equal to delta V, and delta V2 is equal to delta V. So the voltages must be the same because, again, it's Kirchhoff's loop rule. You go around any one loop. So if I follow a loop, let's go around that loop, that the voltage gain from the battery is equal to the voltage taken by the capacitor. So delta V must equal delta V1. Or we can go around this loop and see that delta V must equal delta V2. Okay. And so let's say that we want to know how much charge is on each capacitor. So the first question, I guess, that I ask, A, what is delta V? I'm going backwards. Delta V1, delta V2. B, what is Q1 and Q2? And C, what is equivalent capacitance? Okay, so now let's think about Q1 and Q2. Well, because we know what delta V1 is, because C1 is equal to Q1 over delta V1. So this is B. This was A, sorry. So therefore, Q1 is equal to C1 delta V1, or C1 delta V. So Q1 is C1 delta V, and therefore Q2 must be C2 delta V. Okay, and we're just giving the answers in terms of what's given. And the equivalent capacitance. Oh, sorry, and let me ask a different question before we get to C. So B, the third part of B, is what is the total charge provided by the battery. So therefore, the total charge provided by the battery or power supply, whatever it is, total charge provided by the battery, it provided Q1 to C1 and Q2 to C2. So in this case, Q must equal Q1 plus Q2. It must equal the sum of the two because it charged both capacitors separately, right? Unlike when they were in series, where they were dependent on each other. In this case, they're not. Okay, so therefore, now it's easy to answer part C. Part C was the equivalent capacitance. The equivalent capacitance is the capacitor that takes the same amount of charge from the battery, right? So C equivalent must equal Q over delta V. Let me go to the next page and draw, right? The equivalent capacitance is the capacitor that must draw the same amount of charge, Q, which equals Q1 plus Q2, minus Q, and C equivalent. So the equivalent capacitor is total Q over delta V. So the equivalent capacitor is Q1 plus Q2 over delta V. And Q1 over delta V is just C1, and Q2 over delta V is just C2. So equivalent capacitance is equal to C1 plus C2. So notice that in parallel, capacitors add. With resistors in series, they add. So the rules for resistors and capacitors reverse themselves, right? So for capacitors in parallel, they act like resistors in series, and for capacitors in series, they act like resistors in parallel. So how many giraffes can you fit in a taxi? None. The taxi is full with elephants.